Okay, so imagine this. There's a mathematical theory out there, right? And it's so out there, people literally started calling it the aliens language.
Yeah, it landed like that back in 2012.
And for over a decade, it's just been sitting there. Most mathematicians, even the top ones, couldn't really make heads or tails of it.
Pretty much impenetrable.
But now something's happening. We're seeing maybe the first real glimmer of understanding. And the person involved, definitely not who you'd picture.
No, not at all. And it all circles back to this really deep puzzle in math, something called the ABC conjecture.
Right.
Think of it as like a major unsolved problem. It tries to connect adding and multiplying whole numbers in this really fundamental, unexpected way.
Adding and multiply seems basic, but you're saying the connection is deep.
Oh, yeah, super deep. And proving it. That would change a lot in number theory.
Okay, so that's what we're diving into. You've pulled together some fascinating sources, articles mapping this out, the background, the personalities, even a peek at the research abstract.
We have.
Our mission here is to untack all of that. What is this aliens language? Who's this unexpected person making waves? And, why is this causing such a buzz right now?
Sounds good. Let's start with the theory itself. It's called Inter-Universal Teichmüller theory. Thankfully, everyone just calls it IUT.
IUT. Got it. Much easier.
Yeah.
And it came from Shinichi Mochizuki, a Japanese mathematician, back in 2012.
Correct. And its purpose, right from the get-go, was huge. It was presented as a potential proof for that ABC conjecture we just mentioned.
So not just some abstract exercise.
Yeah.
It was aimed squarely at one of math's biggest unanswered questions.
Exactly. And proving ABC, it's not just like solving one riddle. The sources really emphasize this. If IUT works and proves ABC, it could sort of automatically solve or simplify other huge theorems.
Like which ones?
Well, big names. Fermat's last theorem, for instance, Roth's theorem, the Mordell conjecture. These are problems that took, centuries or incredibly complex modern math to crack. A verified ABC proof could potentially streamline them significantly.
Okay, that definitely raises the stakes. But then the aliens language part, why did it get that?
Now, well, this wasn't just hard math in the usual sense. Mochizuki's papers, they were over 2,000 pages long.
2,000.
Yeah. And they introduced completely new concepts, new symbols, a whole new framework that's just nobody recognized. It felt like it came from somewhere else entirely.
So it wasn't just disagreeing with the proof. People couldn't even follow the argument.
Precisely. Forget verifying it. Most experts couldn't even figure out what was being claimed step by step. It was a communication barrier. And the sources have this great quote that captures it. From Kato Fumimon, an expert in the field. He literally compared it to hearing an alien speak. You hear sounds, maybe repeated, but understanding. Zero progress.
Wow.
And even today, after a decade, the estimate is maybe 20 people worldwide have some real grasp of IUT. It's been that isolated.
Okay, so this potentially revolutionary work is just sitting there like a message in a bottle nobody can read
Yeah.
for years.
Until Zhu Zongpeng enters the picture. And this is where the story gets really interesting.
Tell me about him. He's young, right? 28?
Yep, 28.
Yeah.
And here's the kicker. He's not a professor. He wasn't even in academia in the traditional sense. He had left his PhD program in 2023 with a master's degree.
Okay.
And he was working as an algorithm engineer at Huawei, a tech job.
An engineer at Huawei, not exactly the profile you'd expect for deciphering alien math.
Not at all. But the articles point out his real love, his passion, was number theory, even though his PhD assignment had been graph theory, apparently.
So he kept that passion going on the side.
And how? The sources paint this picture of incredible dedication. He's working these demanding tech hours, like 12, sometimes 14 hours a day.
Wow.
And then going home, and on weekends, diving into Mochizuki's 2,000 pages of IUT, teaching himself this alien language in his spare time.
That's some serious commitment, just chipping away at it alone.
Seems like it. And over about 5 months doing this, he produces this detailed paper, not just understanding bits, but suggesting refinements to IUT, finding new ways to apply it, and crucially, deciphering key parts that had apparently stumped the few experts working on it.
Okay, so he makes a breakthrough. What does he do? Send it to a journal.
He sends his findings directly to Mochizuki, the creator, and also to Ivan Fisenko.
Fisenko.
Yeah.
He's one of the few who does understand IUT, right? Now at Westlake University.
Exactly. A leading expert. And Fisenko's reaction, according to the sources, was just immediate. No beating around the bush. The quote is, apparently, "Come to Hangzhou quickly. I will reimburse your airfare."
Get here now, I'll pay.
Right.
That says everything, doesn't it? Fisenko clearly saw something huge.
instantly recognized its significance, it seems. And things moved fast for Zhu after that. He resigned from Huawei.
He quit his job.
Yep, quit the tech job, and now he's a visiting student at Westlake University in Hangzhou, working directly with Fosenko.
Wow. Okay, so let's connect this back. You mentioned Fermat's last theorem earlier. How does Zhu's work relate to that? Just remind us what Fermat's last theorem is.
Sure, it's that famous problem. Basically says you can't find three positive whole numbers like a, b, and c that solve the equation a to the power of m plus b to the power of n equals c to the power of n.
Right, like a plus b equals c, which was c plus d.
Nice, right.
Works for triangles, Pythagoras.
Exactly. But if that power n is anything bigger than 2, like 3, 4, 5, whatever the equation, has no whole number solutions. Simple to state, but it took over 350 years to prove.
And that proof was a huge deal, right? Andrew Wiles in 1995.
Monumental. Wiles used incredibly sophisticated tools from modern mathematics built up over decades. Algebraic geometry, number theory. His proof was brilliant, complex, and about, 130 pages long?
130 pages. Okay, so how does Zhu's IUT work connect?
This is where it gets potentially game-changing. According to Fosenko, who's now mentoring Zhu, Zhu's used IUT to prove, well, not just the classic Fermat theorem, but the vast majority of cases is something even harder, the generalized Fermat's last theorem.
Generalized. What does that mean?
It's a broader version dealing with equations like a Seth plus b with certain conditions on x, y, and z. It's related, but even more complex. Wiles's proof was specifically for the a plus b use case.
Okay, so Zhu tackled a harder version using IUT.
That's the claim. And here's a really startling quote from Fosenko in the sources about Zhu's results. They are infinitely stronger than Wiles.
Infinitely stronger. Wiles's proof is legendary. What does infinitely stronger even mean here?
It's a bold claim for sure. The implication, highlighted in the articles, is partly about elegance and power. If Zhu's method, derived from IUT, holds up and can be applied back to the standard Fermat case, the suggestion is it might be possible to prove Fermat's last theorem in perhaps just one page.
One page, compared to Wiles' 130.
Exactly. That contrast suggests IUT might offer a much deeper, more fundamental perspective than even the powerful tools Wiles used. It hints at the sheer potential power locked inside this alien language if Zhu has found a key.
That's incredible. It implies IUT might be seeing connections that were totally invisible before.
Possibly. Though we absolutely have to include Zhu's own perspective here. The sources mention he posted something on social media, very modest.
Oh, what did he say?
Something like, those papers are based on the research of predecessors. My work has only made some minor innovations and explorations, and I hope to contribute a modest amount to the relevant field.
Huh. Quite the contrast between minor innovations and infinitely stronger.
It really is. Shows maybe his humility, or perhaps just the cautious perspective of someone deep in the technical details versus the excitement of someone seeing the bigger picture implications.
It also makes you wonder, doesn't it? How does someone, working outside the main academic track, juggling a demanding job, find this insight?
That's a fascinating question the sources raise implicitly. Maybe that distance gave him a fresh perspective. Less pressure to follow established paths.
Or maybe just pure, focused dedication on a single, massive problem.
Could be. We don't know for sure, but the story itself is a powerful reminder that breakthroughs don't always come from the expected places.
Definitely. Okay, let's broaden the view. We've talked about pure math, number theory, Fermat. But why should someone listening, maybe someone not deep into math, care about all this? This alien IUT, this engineer Zhu, what are the potential ripple effects?
Well, the experts quoted in the articles are thinking beyond just number theory. If IUT really holds up, if it becomes more understood thanks to work like Zhu's, it could genuinely shift how people approach mathematics itself.
How so?
By potentially making really hard problems easier, or revealing connections that open up totally new areas of investigation. Think of it like getting a new, more powerful lens to look at the mathematical universe.
And the sources mention specific fields where this might actually have practical applications down the line.
They did. Cryptography is one.
Makes sense. Relies heavily on number theory.
Exactly. Also quantum computing, which deals with fundamentally new types of computation and information. And even theoretical physics.
Physics. How would abstract number theory connect there?
At its deepest level, IUT seems to be about fundamental structures, symmetries, relationships. Understanding those could potentially shed light on patterns in nature, maybe even aspects of space and time. The connections aren't direct yet, but the potential is there.
So new ways to secure data, build quantum computers, understand the universe, potentially.
Potentially. It's all based on getting a better handle on these deep mathematical structures that IUT seems to touch.
But it's crucial to add that caveat the sources mention, right? Zhu's work, as significant as it seems, isn't like the full Rosetta Stone for IUT yet.
Oh, absolutely not. It's presented as a major step forward, maybe the first truly significant step in applying and refining IUT by someone other than its creator. But IUT is vast. This is likely just the beginning of unpacking it all. It's ongoing work.
The first beachhead on the alien shore, maybe?
That's a good way to put it, yeah.
So, looking back at everything we've covered from these sources, it's quite a narrative. You've got this theory, dismissed by many as impenetrable, the alien's language.
Understood by only a handful of people for a decade.
Then comes this young engineer, working late nights after a demanding day job, driven by pure passion.
Who manages to find a way in, makes real progress, and potentially uses it to develop methods infinitely stronger than existing proofs for classic problems.
And suddenly this obscure theory might have implications for cryptography, quantum computing, maybe even physics. It's kind of a wild story.
It really is. And it speaks volumes about, pursuing knowledge, even if it's outside the conventional path.
Yeah.
Zhu's contribution seems undeniable, even if it's not the final word. It's a remarkable step.
So here's something to think about as we wrap up. What does this story, this whole situation with Zhu and RUT, tell you about where the next really big ideas, the truly disruptive breakthroughs in complex fields, might actually come from? Or maybe think about this. How could something as abstract, as seemingly disconnected from everyday life as this mathematical alien's language, eventually filter down and reshape our practical world in ways we probably can't even imagine right now? Gives you something to ponder.